Hello everyone. Today, we're diving into a fascinating topic, how computers work. Whether you're tapping away on a laptop, navigating a desktop setup, or swiping through your smartphone, have you ever wondered what's really going on behind the screen? In this video, we'll break down the core components, explore how they interact, and uncover the magic that turns code into action. From hardware to software, we'll make the complex world of computing simple and exciting. So, grab your curiosity and let's get started. A computer is an electronic device that takes in information, processes it, and gives you results. But it's not just the bulky desktop on your desk or the sleek laptop in your bag. Computers are everywhere. Your smartphone, tablet, smartwatch, and even smart home devices like thermostats and voice assistants are all types of computers. They may look different and serve unique purposes, but at their core, they all follow the same basic principles: input, processing, and output. Understanding this can help you see the hidden tech world around you and appreciate how seamlessly it powers your daily life. Let's break down the main parts of a computer and see how they work together to bring your digital world to life. First up, we have the CPU, or Central Processing Unit. Think of this as the brain of the computer. It's responsible for all the thinking, decision-making, and calculations. Every time you open a file, run a program, or play a game, the CPU is working behind the scenes to make it happen. Next is RAM, or Random Access Memory. This is like your computer's short-term memory. It temporarily holds the data and tasks you're working on right now, helping your system run faster and more efficiently. The more RAM you have, the more smoothly your computer can multitask. Then there's storage, which comes in two main types: HDDs, or hard disk drives, and SSDs, or solid-state drives. This is your long-term memory, where all your files, photos, videos, and programs are saved. SSDs are faster and more reliable, while HDDs offer more space at a lower cost. At the heart of it all is the motherboard. This is the main circuit board that connects every component together. It's like the central highway system, allowing the CPU, RAM, storage, and other parts to communicate and work in harmony. And finally, we have input and output devices. These include your keyboard, mouse, monitor, speakers, and more, basically anything you use to interact with the computer. Input devices let you give commands, while output devices show you the results. Together, these parts form a foundation of every computer, working in sync to deliver the experience you rely on every day. Let's take a moment to imagine your computer not just as a machine, but as a living system, one that listens, thinks, and responds. Every time you interact with it, a silent conversation begins. You press a key, click a mouse, or tap a screen. That's the input, your way of telling the computer what you want. Now, deep inside the computer, something remarkable happens. The CPU, often called the brain of the computer, springs into action. It takes your input and begins to process it. It deciphers your command, runs calculations, checks instructions, and prepares a response, all in fractions of a second. Then comes the output. The result of all that processing appears before you. Maybe it's a letter on the screen, a sound from the speakers, or a printed page. Input, process, output. It's the heartbeat of computing. To visualize it, imagine a simple flowchart. Input, process, output. Like a conveyor belt of factory, each step leads smoothly to the next. But behind this elegant flow lies a powerful partnership: hardware and software. Hardware is everything you can touch. The keyboard you type on, the monitor you look at, the mouse you move, and the internal components like the CPU and memory chips. It's the physical structure, the skeleton of the computer. Software, on the other hand, is invisible. It's the set of instructions, the programs, the apps that tell the hardware what to do. It's the intelligence that guides the machine's actions. Without software, hardware is just a lifeless shell. Without hardware, software has no vessel to live in. Together, they form a symphony of logic and design, a dance of electrons and ideas. And every time you use a computer, you're conducting that symphony, one keystroke at a time. Now that we understand the partnership between hardware and software, let's talk about the operating system, or OS. The OS is like the manager of your computer. It coordinates all the hardware and software, making sure everything runs smoothly. When you open an app, save a file, or connect to Wi-Fi, the OS is working behind the scenes to handle your requests. Popular operating systems include Windows, Mac OS, Linux, Android, and iOS. Each has its own look and feel, but they all serve the same purpose: to bridge the gap between you and your computer's hardware. The OS manages resources, keeps your files organized, and provides the interface you use every day. But doesn't stop there. The OS also handles multitasking, allowing you to stream music, browse the web, and download files all at once without crashing your system. It allocates memory, prioritizes tasks, and ensures that each program gets the resources it needs to function properly. Security is another critical role of the OS. It protects your data, manages user permissions, and defends against unauthorized access or malware. Whether you're logging into your device or installing new software, the OS is constantly working to keep your system safe. And let's not forget updates. Operating systems evolve over time with regular updates that improve performance, patch vulnerabilities, and introduce new features. These updates help your device stay compatible with the latest apps and technologies. In short, the OS is the unsung hero of your digital experience. It's the silent conductor of your tech orchestra, making sure every component plays in harmony. Without it, your computer would be just a collection of parts, powerful but directionless. So next time your device boots up, take a moment to appreciate the operating system. It's doing a lot more than you think. Computers rarely work alone. They connect to each other through networks, forming digital highways that allow us to share information, access the internet, and communicate across the globe. Networking is what lets you send an email to a colleague halfway around the world, stream your favorite show in real time, or browse the web for answers in seconds. It's the invisible infrastructure that powers our digital lives. At the core of networking are protocols, sets of rules that computers follow to exchange data reliably and securely. Think of protocols like languages that devices use to understand each other. One of the most important is TCP/IP, which breaks data into packets, sends them across the network, and reassembles them at the destination. The most well-known network is, of course, the Internet, a vast, decentralized web connecting billions of devices worldwide. It's not owned by any one person or organization, yet it's the backbone of modern communication, commerce, and culture. There are also local area networks (LANs), which connect devices within a small area, like a home, office, or school. And wide area networks (WANs), which span larger geographic regions, linking cities or even continents. Thanks to networking, computers have evolved from isolated machines into powerful tools for collaboration, learning, and entertainment. We can work together in real time, attend virtual classrooms, play multiplayer games, and share ideas instantly. And as technology advances, networking continues to grow. Faster speeds, smarter connections, and more secure systems. From fiber optics to 5G, the future of networking is all about making the world feel even more connected. So next time you send a message or stream a video, remember, behind the scenes, a complex network is working tirelessly to bring the digital world to your fingertips. Computers are constantly evolving. We've come a long way from room-sized machines that required entire teams to operate to sleek, powerful devices that fit in our pockets and connect us to the world in seconds. But the journey doesn't stop here. Emerging technologies are redefining what's possible and opening doors to a future that once lived only in science fiction. Artificial intelligence, AI, is at the forefront, making computers smarter and more intuitive. AI systems can now recognize speech, translate languages, diagnose diseases, and even create art. They're learning from data, adapting to new situations, and helping us solve problems faster than ever before. Then there's quantum computing, a revolutionary leap in processing power. Unlike traditional computers that use bits, quantum computers use qubits, which can represent multiple states at once. This allows them to tackle complex problems like molecular modeling, cryptography, and climate simulations that are beyond the reach of classical machines. Meanwhile, the Internet of Things, IoT, is transforming everyday life. From smart thermostats and wearable health monitors to connected cars and intelligent cities, IoT is embedding computing into the fabric of our environment. These devices communicate with each other, gather data, and respond in real time, making our world more efficient, responsive, and personalized. And let's not forget edge computing, augmented reality, and neural interfaces, each pushing the boundaries of how we interact with technology. The future of computing is not just about faster processors or smaller devices. It's about creating systems that understand us, anticipate our needs, and empower us to do more than we ever imagined. It's a thrilling journey, and we're all part of it. Whether you're coding the next big app, exploring virtual worlds, or simply asking your smart speaker for the weather, you're contributing to a digital evolution that's reshaping how we live, work, and connect. So as we look ahead, one thing is clear. The future of computing isn't just coming, it's already here, and it's only getting more exciting. We've taken a fascinating journey through the world of computing, starting with the core functions of input, processing, and output, and diving into the essential roles of hardware and software. We explored how the operating system acts as the brain behind the scenes, orchestrating every task and interaction to keep your digital experience seamless. Then we zoomed out to see how computers connect through networks, enabling global communication, collaboration, and access to information at lightning speed. And finally, we looked ahead to the future, where artificial intelligence, quantum computing, and the Internet of Things are reshaping what computers can do and how they interact with our world. Understanding how computers work isn't just about technical knowledge, it's about unlocking a deeper appreciation for the tools we rely on every day. It empowers us to use technology more effectively, think critically about innovation, and stay curious about what's coming next. So whether you're a student, a tech enthusiast, or just someone who wants to understand the digital world a little better, thank you for joining this exploration. Keep asking questions, keep experimenting, and most of all, keep discovering the wonders of computing. Thanks for watching, and I'll see you in the next chapter of this digital adventure.